Thank you, Angela. Thank you, everybody, for joining us today. This is the panel entitled The Future of Jamstack and Serverless. We have 3 distinguished panelists who will be joining us, and I hope that you'll take away some lessons about how we got where we are today with both Jamstack and Serverless, how they're starting to align and how they're starting to diverge, and how we can project some of those trends a little bit out to expect what we'll be building soon in the future, what the future of these 2 technologies holds. So, without any further ado, I'd like to introduce our first panelist. He's the co-founder and CEO of Netlify. He coined the term Jamstack in 2015, and he's since driven the successful adoption of the Jamstack across enterprises, startups, indie developers, web agencies, and more. Please join me in welcoming to the stage Matt Biilmann. Our second panelist, I think you'll all be familiar with. He's the general manager of Serverless Cloud at Serverless Inc. He hosts the Serverless Chats podcast, and he creates and publishes the weekly Off by None Serverless newsletter. Please welcome back to the stage, Jeremy Daly. And our final panelist is the CTO of Begin, the platform that makes serverless absurdly easy. He's also one of the maintainers of Architect, the framework for building functional web applications on AWS. He's been well known in the serverless community ever since the introduction of AWS Lambda in 2015. Please join me in welcoming to the stage, Brian LeRoux. Thanks for joining us.
Not again.
All right. I told Brian when he arrived this morning there's easier ways of getting out of talking to me, but he was committed to the bit. So, the future of Jamstack and serverless. And I want to start with where these 2 technologies intersect and where they're starting to diverge. Or, as we discussed a little bit before, Jamstack versus back-end serverless. Because that's where we started. Originally, Jamstack was oriented around how do I get this HTML out to the client as quickly as possible, and serverless was over here saying how do I do things hidden in the back room on line of business applications. And of course, it's a gross oversimplification, but it's a starting point. It's not exactly the same anymore. Is this distinction meaningful, or are we starting to see a collapse of the 2? And I'll ask you, Matt.
I think this distinction is still very meaningful. I think serverless covers a very broad range of what people are building, right? Like from serverless event processing for analytics systems and background tasks and all of these kind of things, where Jamstack from the beginning was really oriented around a shift in the architecture for how we built for the web. And that was sort of our core insight and idea behind starting Netlify, that we saw that you would start fundamentally decoupling the web UI layer from the whole backend business logic layer, where before this, like the normal approach to building any kind of web property was like having a big monolithic full stack app that coupled business logic, templates, plugins, data access all together in systems like WordPress, Drupal, or experience managers like Sitecore, AEM, Episerver, or in like application frameworks like Ruby on Rails or Spring or so on, right? Like where you really started building this idea of like a monolithic thing that did everything. And we saw this shift away from that approach to treating the web UI layer as a standalone thing that you can work on in isolation, deploy in isolation, get as close to your users as possible, and that has its own workflow surrounding it. And what we saw the possibility to do when we realized that that change was going to happen was to really build an end-to-end cloud platform around that web UI layer that incorporated both the runtime layer, the hosting and so on, but more importantly, the whole workflow layer for how do you release, how do you operate, how do you deploy, how do you collaborate on building web properties with modern web technologies. And I think where the ideas intersected, like obviously we were the first in the space back in 2017 that incorporated AWS Lambda into this kind of cloud platform. And that's now become sort of the standard, right? Like you have edge hosting, you have serverless functions. We're starting to see edge functions emerge as a standard layer of it, right? And we did that because we saw that often the web teams working on this web UI layer, they didn't just need to build just HTML and CSS and JavaScript and deploy that, right? Like they also needed a sort of a backend for the front end, right? Like this whole layer that you talk to all the different APIs and services through. You needed functionalities like scheduling, background tasks, and so on. That's still inherently tied to the team that builds the web UI. It's not a part of any of the API teams and so on. But that until this point required like spinning up a server somewhere and suddenly becoming a system administrator and running it, right? Like, and our philosophy about like that whole web UI layer was that we should strive towards a point where the web teams could just work in GitHub, write code, and the rest would flow from there, right? Like, so we saw a great opportunity of incorporating like serverless functions and latest like Dino edge runtimes into this flow, and keep that promise of just letting you write code, and then the rest happens there. And I think where there's a really interesting convergence now is, I think we're seeing in the serverless space that's like sort of outside of just the web UI layer, but the whole like how do we build the APIs that people are talking to, or how do we build the infrastructure services that does more complex background processing and tasks and so on. We're starting to see these same ideas emerge of like, how can we get to a point where the teams working on that can just write the code and the rest flows from there. And that's been exciting to see, like from serverless cloud, like moving into that direction. It's a direction I believe a lot in.
And I think that's what I would take your question there. How do we build those aspects of managing the data and the workflows? And I think that's a natural segue into this question for you, Jeremy, with something like serverless cloud. You and I have talked about the front end generates a lot of data, and it eventually, when you become successful only as a front end developer with a web app, you now have all this data and you have a new need for a back end application. So what does the growth path look like out of what's currently offered when you have to start building with line of business applications that you never expected to handle?
Well, I think that's the other thing. Matt makes a good point. I mean, there is a separation to some degree of building a front end, product website with some dynamic components that still has some functionality that needs to be written and needs to generate dynamic things, and adding edge functions and doing all that kind of stuff and integrating with serverless so that you can do some of that processing. I mean, again, what you're doing with Netlify Graph, like that's really cool because you're taking away a little bit of that heavy lifting of having to do authentication and kind of building that in. Makes things, oh, that's perfect. Makes things a little bit easier. But I think certainly what I've seen is I don't think I've built a website that just does, calls a couple of APIs or whatever. I don't think I've built that in the last 6 years, right? I mean, essentially every application we're building seems to have some sort of line of business that it is actually powering. So, and every type of application you're building on the back end most likely has a front end, even if it's internal, right? So in some of those cases, you don't necessarily need the edge and all these other things, but in some cases, you're building very complex administrators or, whether it be social media or anything that's very heavily data-driven. In some of these cases, just a static site, even static sites that are, incrementally regenerated or have some rehydration, aren't necessarily cutting it for some of these larger applications. And so what we try to do at Serverless Cloud is say, that natural front end, that ability to build things quickly, to distribute things around the world, that is a very solved problem. I mean, I don't want to say 100% solved, but Matt and his team and Guillermo and Vercel, like what they've done is they've revolutionized that sort of process. And I think that has gotten us to a point now where it's like, hey, we can almost, I don't want to say commoditize that because that's not the right way to say it, but essentially that piece is like a foregone conclusion. So now how do we get people to the next thing? How do we get them to say, okay, now we're collecting all this data from the front end, or we want them to be able to, run all these complex applications behind the scenes. We want to be able to, have WebSockets open because we want to wait for a particular thing to respond, and we don't want to do that synchronously. Or, what are all of those different complex applications that people are building and thinking up now? what are those things, what are the interfaces into those things, and how do we make that so that you don't have to have one team that's building on this platform and another team that's figuring out CDK and these other things on this platform, and then saying like, oh, and then we're going to use this other database here, we're going to use Fauna, or we're going to use PlanetScale, or we're going to use this, and now you're managing all these different services with multiple teams that aren't necessarily communicating with one another. So I wonder, with the split of front end and back end sort of as two types of developers, I feel like that's merging now, and everything is becoming full stack. So I think Jamstack is naturally evolving to full stack. I think you'll still have some people who will be focused, and again, I could give it up to people who build on Next.js or any of these front end frameworks, because it's more complicated than what I do on the back end, I can tell you that. But like, I think those skills transfer just fine, and as long as you give someone a platform that allows them to do that, those applications can be built full stack all the way through. You just have to take out what Netlify and Vercel did with reducing the complexity of deploying those sites globally at the edge and the CDN. We have to do the same thing to deploy the back-end line of business applications.
Right. Well, and from that perspective, the segue for me then, you talked about these disappearing frameworks is what I call them. It's convention over configuration, where when you deploy something to your provider, whatever's in the Pages API directory in Next.js, for example, gets deployed as functions. Where? I don't care. It doesn't matter to me. You just do it. But also at a certain point, I might start caring.
Right.
I might have other reasons why I want that on provider A instead of provider B, or I want it at the edge instead of on general regional compute. Brian, what do you think about the idea of these disappearing frameworks? And is that something that we could see on the back end as well, this convention over configuration option to speed up this process?
I hope all these frameworks start disappearing. That'd be great.
I thought you might say
that. Yeah. In seriousness, I think Jeremy touched on it really beautifully. This is a moment for the web developer. And the front-end web developer didn't even used to really be a job. That was like a fairly recent thing, actually. If you were a web developer, that meant you did the whole thing. And then frameworks got involved. And the frameworks at that time were things like Spring and worse. And you weren't even writing HTML, you were writing Java, and there was kind of HTML in there, and the JavaScript was sort of this separate thing, and these worlds diverged. And what we're seeing happen right now is the web developer, the front-end web developer, is becoming empowered to take that back and write that code themselves and deploy it themselves and run it themselves and architect those systems themselves. We don't need to load balance monoliths anymore to get a dynamic application running, and that's a wonderful thing.
Yeah. Is there, and this is for anyone that wants to answer it, is there an aspect of the disappearing framework for the back end, or meeting developers where they are, maybe is another thing, where in the case of Next, it brought into React the functions. So think about something like Spring. We all like to dig at Spring or Rails or whatever, but the fact is there's a tremendous amount of websites out there that are built around that. Why haven't we seen okay, thank you for your Rails app. Here it is deployed as a collection of SQS for sidekick queues, step functions for worker tasks, Lambda functions for your routes, et cetera, et cetera.
Some of that's
So
happening.
I would just return to this idea that the Jamstack is going full stack, which you really don't agree with, actually. Like, I think maybe it comes with like the kind of clients we work with and so on, right? But take Twilio, right? Like more than 3,000 developers, like 60 billion market cap company or something like that, right? Like if you go to Twilio's logged in experience, all of that runs on Netlify from the web UI perspective, using like a federated approach to have like hundreds of different teams working across different areas of the console, with different front-end frameworks, technologies, and so on, right? And obviously, the backend services that they consume, Twilio's messaging API, their call center APIs, and so on, have whole teams around them that specialize in them, that build them, that work on them, and so on, right? And I don't see any interest from Twilio in saying, hey, we want all of these 3,000 developers to work on like one full stack application. On the contrary, it's like a feature, not a bug, that you can actually like say, here's the web UI team. They have like their straight path to iterating really fast, to deploy like hundreds and hundreds of times a day, to move at a different speed that any of their backend services can move on. And each of those service team can work in isolation. And we are seeing that even from an ecosystem perspective, where you sort of outsource a lot of those backend service teams, right? Like where you say, okay, we need authentication. Let's pull in Auth0 as a service, and we've basically outsourced that whole service team to an external company. We need content management.
Serverless, by the way. It's outsourcing.
Absolutely right, but I
Yes.
think that's where I'm thinking on like different than just putting everything in one big CDK file and with one framework driving everything. I think we actually see this decoupling move to a world where everything is composable, and where I think we'll see real serverless frameworks emerge and tool stacks emerge is around like how does the teams that are building those APIs and services to be composable and to be part of this landscape, how do they execute faster? How do they build faster? And how do the developers that needs to glue them together, typically with like background tasks, with like pops up services, with all of that, how do we make life as easy for them as for the teams iterating on the UI experience, right? Like, and I think there we'll see a lot of innovation in the next couple of years.
Yeah, I mean, and I mean, again, I think I think your premise there is right, but I also think it's very much so about choice. So, I mean, one of the things we do with Serverless Cloud is you can build a front-end component and build that in one app, and then you can build your back-end component in another app. So you can have multiple teams managing separate things. But for the team that's building a back-end app that wants to have a quick admin and wants to be able to deploy some HTML to support that, whether it's a SPA or it's something more complex with Next or whatever, they have the choice to do that, right? And so that to me is where what worries me about abstractions, and this worries me about Serverless Cloud, it worries me about architects, it worries me about any abstraction, is that you get to a point where what happens when you hit that limit? You mentioned the idea of convention over configuration. Well, as soon as you can't write your own configuration, you can't make those decisions for yourself, it gets very, very limiting. And so, I mean, again, I look at that, we use Netlify to power the dashboard for Serverless Cloud, for example, right? Even though we could host it ourselves, Netlify works great for it, and it's a good part of the process. We've got that separated. But if we wanted to build our back end completely integrated as an admin, we could do that all through one single application with plenty of choice. But again, I do think that it is about how different teams work, and I think teams work very differently now. And then the only other thing I'd say too is that I'm on a mission here to replace WordPress. I don't know about the rest of you, but if we could get rid of WordPress, that'd be amazing. I think we got like 90% of sites to work on. But that to me is something where something like WordPress with all the plugins and all these other things that it can do, it's so hard to get away from WordPress because it does all those things for you, right? And so, and you can build a lot of that stuff with serverless functions on Netlify or Vercel as well, but giving them more capabilities and giving maybe even an ecosystem where some of those plugins could live in a serverless type world is a future that I would very much so like to see. So I do think that you've got millions of developers who would want to build a full stack application that it could be as simple as a website front end that connects to your HubSpot API, right? And then you can do that in a million different ways, but it may be more complex. So I think the idea is to try to find a way, and again, not any specific framework either. I'm not talking about a framework. I'm talking more about just a convention that we can come up with that will allow us to do this, which is why we talk about infrastructure from code. But essentially giving you that full framework, or I don't want to use that word, that full process to allow you to deploy those things and replace your WordPress sites. That's where I want to get.
So I want to dig into a thing here, and I think it's important to be specific about terminology, because I think words are important, and I think it's important to be very specific about what we mean by serverless when we talk about serverless. So WordPress is kind of serverless if you use their hosted thing. If you run it yourself, you're no longer really serverless, and that's okay. So serverless, to me anyhow, isn't a particular technology. It's an ethos about outsourcing. It's an idea that there's going to be someone out there that does this, thing that I don't do. Like, I don't rack servers anymore. I used to do that.
Yeah.
And now I rent them by the millisecond from Amazon because they do that. And they're going to have way better people doing that than I'll ever be. And so in a sense, like, things like WordPress are okay. Like, if you're building a blog right now, it might be worth examining that as a good use of your time. WordPress has been doing that for a while. Maybe just let them do that, and you can focus on your business problem. Now, it's cool to build a blog. I'm not saying you're bad if you built a blog. Go for it. It only takes 3 minutes. It's fine to do that. But, to build WordPress doesn't take 3 minutes. It takes a lot of time. And so in a lot of situations, it is serverless to do that. This word serverless has grown ambiguous and kind of problematic, and so it's hard for us to be specific when people say, oh, serverless is functions or serverless is this particular framework or product, because it really isn't. Serverless is about focusing on your code and your business logic, which is hopefully unique. Because if you're not writing unique code, you're not creating something that's uniquely valuable, which is a really bad use of your time. And you don't have a lot of time in this life. So you might as well spend it on doing something valuable and outsourcing that stuff.
Well, I had saved this topic for later for
Oh,
us
sorry.
because I know
I
this
screwed the
goes
whole
on, but no, now we're going to dive right into it. Whenever serverless people gather,
They argue about
two things inevitably come up. One is serverless has servers, and yes, we all know. The second is, do we need new words
Yes.
around this?
Yes, so this has been my thing that I've been dragging around lately. I've been calling them functional web apps. So serverless doesn't mean anything. It's too ambiguous. It's about an ethos, but it gets applied to marketing. Functional web apps is a term that we're coining, or saying FWAs, so that we can be specific about what we're talking about. And what we're talking about is building with Cloud Functions as your primary abstraction, deploying with a managed database, and using infrastructure as code. And these are all just really good practices to have anyways, and it's a 3-letter acronym so you can remember it. So when when I'm talking about functional web apps, I'm not talking about Kubernetes.
Yeah. The great heisting of the term cloud native.
Yeah,
or
cloud
the Cloud
native,
Native Foundation
yeah.
was one of the great crimes against computing in the
Right.
2010s. I posit.
Yeah,
Not
so
without-
cloud native gets associated to Kubernetes, which is essentially running your own servers.
Yeah.
This is like the opposite of cloud native.
Right.
But for me, I mean, Jamstack is cloud native. Serverless applications are cloud native. You're taking advantage of the
Yeah.
other providers there so that you can create value for your users by
Yeah.
writing code specific to your business processes or creating a front end that improves the developer experience for them. So I agree with you that words matter and we may need a replacement. The first time I ever met you, I don't know if you remember this, was in August of 2019 at the Serverless Heroes event. I just started at AWS. And one of the topics on the internal panel was, do we need a new word?
Remember that?
I hope it's okay that I say that. Now you all know. But I remember like the very first day that I met you, it was, do we need a new word? And of course, some people like the word.
Yeah.
But this does come up a lot. I want to ask you the same question, but around Jamstack. Like, has
Yeah.
the ecosystem evolved so much that JavaScript APIs managed services is no longer an accurate reflection of it?
I mean, a while ago we changed the way we put Jamstack from being capital, from the abbreviation originally, to just being a word, because it felt like the core tenet of it was much more this idea of decoupling than the specifics. I still think there's a strong sense of the decoupling, meaning that you build a sort of stateless UI layer and consume a bunch of different APIs rather than building like a full stack, everything, templates, plugins, business logic, data access coupled together. I think where we've seen a lot of evolution and are seeing a lot of evolution right now is like, even in that stateless UI layer, where does stuff actually run, right? Like in the early days when we started Netlify, AWS Lambda wasn't really a thing, right? Like so the only places that code would run would be during a build time or in the user's browser, right? Like then when we introduced serverless functions as part of Netlify in 2017, we started seeing this idea of like some code being build time, some code being browser, but also a bunch of code being possible to run in serverless functions, still typically just like stateless functions deployed with the rest of your UI, right? Then we started seeing new patterns emerge around that, like ISI and distributed persistent rendering and deferred static generation and so on, right? Like taking advantage of that layer. And now we are starting to see this new streaming rendering layer in edge functions become a part of the stack, right? And some people will argue that then we should call it something else than Jamstack. To me, it still feels like it's more about how you use it, right? Like, of course, if you start building a full stack application in edge functions and couple together like data access and business logic, templates, everything in sort of a full stack framework and work with it that way, that's obviously not a Jamstack approach, right? But I think most of the people, like if you look at something like Hydrogen from Shopify, right? Like it's very different than a Jamstack application looked like 5 years ago, because you have this complete streaming rendering layer, but it's still very much the same model, that you have this stateless UI layer that talks to Shopify's API and generates like React rendering streams for you in the end, right? It's just a question of you've shifted the runtime layer from the browser to this streaming layer close to the browser. But architecturally, to me, it doesn't feel like a fundamentally different approach. It feels like mentally you have a build step, you push that out to the edge, you have an API that you stream from and talk to, and not surprisingly, it runs really well on a platform like Netlify's, right? So I think it's a good question of whether we need a new name. Like, I think the challenge with any of these architectural names is that, like, just like with serverless, from the day you coin them, people will start saying, like, we should coin another name, right? I'm probably at this point in the stage of, like, let's keep it as long as it makes sense, and I think it still totally makes sense.
I think there's a shared understanding still, even if we don't like the term, of what we mean when we say Jamstack Serverless, less so.
Yeah.
So I think there is that argument for changing.
Well, I think the term serverless too has just is gotten to the point where everybody labels everything serverless. In 2018, 2019, I did talk in at a serverless days conference, and my talk was stop calling everything serverless because essentially that's what people did. Everybody was like, well, this is serverless. I mean, that's the thing, like serverless containers. I asked Werner this on the podcast. I said, is there such a thing as serverless containers? And of course, I think, had to give the AWS line of, yes, of course there is. So I don't know if I got a straight answer there, but I mean, some of those things, for a long time, it was sort of bothering me, and that, because I was like a serverless purist for a while, and then I'm just like, you know what, call it whatever you want. I know what I'm building, and actually, I would disagree with Brian just a tiny bit about outsourcing to something like WP Engine or whatever it is, because I do think the technology does matter. It is a little bit about the technology, not necessarily about the technology choice, but like just outsourcing something to WP Engine or WordPress or whatever, or even outsourcing to Elastic.co or something like that. It's not as elastic as it sounds, right? And so there's an elasticity there of, that's one of the tenets of serverless. So scale down to zero, we abandoned that a long time ago. Unfortunately, pay for value or pay for what you use, I think, is what we go with now. But
compute.
Utility, right.
Yes.
But the elasticity of it is still an important piece, and the technology has to do that. And this is one of the things where, if we go back to Jamstack and edge functions, the biggest problem I have with edge functions has nothing to do with the fact that they're super fast and they can stream, they can do all these amazing things. The data replication is the biggest problem. So your best case scenario using edge functions to do dynamic rendering is likely to route to the nearest region, right? So you still are looking at regional distributions. You still have to have some framework or some process for deploying and replicating your data. And then even if you're using like KV or some of these things, if you're doing more complex stuff, you may be routing to an edge function that gives you the ability to do authentication and maybe maybe like rewrites of the origin and things like that. Really great stuff that you can do. But when it comes to actually rendering some sort of dynamic data, you're still going to have to reach out to a data center somewhere. And global tables, right? Solved.
Just everyone get on DynamoDB and we're good.
No, I think that's actually like a really...
I do want to step in here for a second and say there are other options besides DynamoDB global tables. And to find out how to manage your data at the edge today, see my session this afternoon, Building Data-Driven APIs at the Edge. It is not product-centric. It is about the considerations that Jeremy just mentioned. And how do you get around this? Because there are levels of coming in, and there are different parts of that workload that will need the full round trip. And then there are different parts that can be pushed out to cache or cache-like things at the edge, like KV. I apologize.
That's part of, but I totally agree, right? Again, but I think that's also part of why I think that when people really start using, like, it's still a very new thing, right? Like, it's only really now, like, I would say that it's only really since we launched edge functions that you actually have an intuitive way to work with an open standard runtime at the edge layer, right? Like, so we're still in the very early days of this, right? Like, and I think there's a lot of excitement around it. I think as people start building applications in that layer, I think they will actually end up with a very Jamstack-like approach where we've seen approaches like taking the core data that your application need in build time, you bundle a core piece of that with the edge function, and now you can get that whole streaming rendering really fast, and only the data that's not part of that core set you go to APIs for. I think we'll see, like, because I think people, it will also lead to a very different adoption path for tools like Fauna that until now had this promise of like, hey, we are actually building data tools that does true global distribution But anytime people were like, okay, so let's build an app in top of them, they ended up deploying a serverless function to like a single region, and it was like, okay, how do we actually use it, right? Like that's the next part. We'll enable the whole ecosystem to actually tap into tools like Fauna, like Convex, like PlanetScale, and build interesting things of them. But I still think, to your point, that like 2 years from now, we're not going to see every company in the world store their data all over the world, because it's just not feasible, right? Like, so it has to be around like, how do we pre-build some of that data? How do we cache it? How do we build intelligent replication patterns that doesn't replicate everything? And I think a lot of that architecture that emerges around that will look a lot like
Sounds like
this
Netlify's
idea of
building a
a
database.
Jamstack. No, we are absolutely not. Again, because we're not building for these full stack apps. We're treating for like, how do you build this web UI, and how do we make it really easy for you to connect to all the different APIs, databases, data sources that you need both at build time and at runtime, right? Like, but again, we don't believe in like a vertical stack for building this like monolithic application. Again, we believe in this decoupled approach.
I do want to mention one of the other missions besides getting rid of WordPress. If we could eliminate the pulsing gray placeholder boxes, if we could get rid of that, that'd be amazing. That, and then also scroll bar hijacking. If we could get rid of that, all right, and then the world would be a better place.
Yeah, no doubt.
Well, so I can't help you with any of that. But a lot of what we've been talking about really is oriented around developer experience right now. And we've slid in and out of it, and I've been wanting to come back to this topic. But even things like when you think about edge functions and the way that they deploy radically differently, I mean, most of them that I've seen, it's a second. You're looking at second deployment times, which is just not what you see from traditional cloud applications. That can change an entire model for the developer of, listen, I'm gonna push that data all the time on a separate branch, and I have a data branch, and it republishes all of my edge functions so that they have that data as their own cache as constants, right, in the V8 isolate. So that's a really interesting thing that to me is one of these future experiences that we don't really know what it's going to look like yet. So then the question is, what areas are we seeing in developer experience that are sorely uncovered today, and how do you think we're going to go about fixing them in the next 5 years?
I'll ask you to help fix some of them, right? Because like one thing is like that whole web UI layer, right? But then every time one of our teams need to start building a new API for that layer to tap into with all the performance characteristics, observability characteristics, scalability characteristics, release management characteristics that you want, that always turns out to be like a long process of them working together with an SRE team and putting it together and so on. And that's where I think that there's such a huge potential for this idea of infrastructure from code, where what if those teams could also just like start writing code for solving a problem, and the rest would flow from there.
Right, and I think that's you mentioned, of course, edge functions, and those deploy instantaneously. To set up a new AWS account, deploy a CloudFormation stack, to deploy a CloudFront or a CloudFront distribution.
CloudFront,
I mean, you
might as
well take half the day off, right? I mean, so one of the things we did at Serverless Cloud was we said, well, we know this takes forever to do, so what if we just pre-provisioned a bunch of these services that we knew were most likely going to be part of every stack? So that's what we did. We built an AWS account vending system. So when you go and you spin up a new instance, it takes about 3 or 4 seconds, and we just basically update a line in DynamoDB. We're looking at Fauna. Anyway, so you upload DynamoDB, and then basically that says, okay, this account is now associated with this particular user. And so that gives you the capability to then deploy code very, very quickly. And even when you deploy a new instance in Serverless Cloud, it takes about 14, 15 seconds, and then a little bit more if you do a build step. But another thing we're doing too is we're actually running our build step in Lambda functions now with ephemeral storage. So we can do that. We can build, and again, Netlify has a great little game you can play while you're watching your thing deploy and build. We can do it in 30 seconds, right? So we can do that in 30 seconds, actually 30 seconds or less. So there's some really interesting things you can do to speed up the development and to speed up the deployment and some of those things. But where I think the bigger topic is, and this is something we were trying to think of with infrastructure from code, is when you say you put a file in the pages directory, or you put a file in the functions directory or whatever, and then maybe you configure the TOML file or whatever to do certain things. But you're very specifically thinking about, okay, well, this is going to be a function, or this is, and I want this to go to the edge, or I need, or if you're doing, Next.js and you're saying like, I know this is SSR, and you have to, again, I'm not a Next.js expert, but essentially you have to define that this is going to be something that's going to load on demand, or it's going to load SSG, or it's going to generate at build time. Why? Why are we doing that, right? Why not have an application or a framework or just a convention where it says, okay, when you deploy this function that needs to do X, Y, Z, we know that it needs to connect to a database, which means we know that we either have to find a way to optimally route that to a closer data center, or we have to know that there's certain data that can be prepackaged. And even better, what if we could say, look, at this particular edge location, you're always loading this type of data. So why not automatically ship that data there for you automatically? Why can't we figure that out for you? Why does the developer have to do that? And the more you think about, and I mentioned this in my talk, but if I'm deploying an API endpoint, right? I have to specifically say right now that I want that to deploy into a Lambda function. But what if I do want it to deploy into a Fargate container? Or what if I'm using SQS now because that's the right method for me to be polling off of a particular queue? But what if that changes? What if I do need to add SNS in there or whatever? That changes with the use case, not necessarily with my code that I'm writing. So what if the code was, or what if the system was smart enough to figure out this code needs these resources to do that? And then you start looking at things like edge functions, you start looking at things like data replication and whatever. Like if you're getting no traffic in a particular region, well then don't ship data there, right? Don't deploy to that edge. Don't worry about, maybe you have longer caching times or whatever. Like that stuff should be figured out by the platform for you. And that's where I think the developer experience needs to go, is we need to get back to this idea of essentially building WordPress sites, but then just have them deploy to the modern infrastructure that we have around the world now, which is amazing, right? And that's where we want to get, but we got to take that developer experience back to a point where it's very easy for these people to develop, and then not necessarily worry about how do they run it at scale.
All right. So
you look like you want to say something.
I'm going to be the words guy again. So developer experience gets chucked around quite a bit. And sometimes people even pit it against user experience, which is a fallacy. Those things don't have to be against each other. You can have a great developer experience and a great user experience. It's totally possible. Most what people mean when they say developer experience, they're talking about familiarity. So sometimes people will encounter a new project and they'll be like, this is such a bad DX. But what they mean is, I didn't use TypeScript, or it's not using the framework that you knew, it was the one I knew. And that's not actually developer experience. Developer experience is when you've got a bug, it's Saturday, you got paged, and you need to fix it. And now you're like on the clock, on a weekend, you got better things to do, and you've got to fix this thing. That's developer experience. What happens next? It's when you get a new requirement and you've got a deadline next week and you've got to do it this week. That's developer experience. Developer experience is what your day-to-day life is like using the tools that you've selected. And if those tools are a bummer, then you've got a bad developer experience. And if they're awesome, then you've got a good developer experience. And it tends to be when you get better with your tool, it becomes more familiar to you and it seems like less of a bummer to use, and so you'll anoint it as a good developer experience. Developer experience ultimately comes down to clarity about how you can go and fix something or build something. And usually that is familiarity to me. It's also about tight feedback loops. It shouldn't take you 3 minutes to see a change on your website. It should take seconds because we have the technology to do that right now. And if you have a bug, you should know the line number where that bug is. So you can go to that code, fix that code, deploy it in a few seconds, verify it that it's been fixed, promote it to production, and then go drink mimosas because it's fucking Saturday. And that's what you want to actually be doing. That's developer experience to me. How that manifests really depends on framework to framework, but for me it's about having great local dev and great visibility and observability into your system when it's running.
Didn't prepare this topic, but let's talk about observability, because I think this is one of the things that comes up, especially with serverless and Jamstack applications. You no longer have an agent in your container watching your memory and your CPU usage, right? You now have everything distributed everywhere. What have you learned or what have you seen as the most appropriate ways to address that?
For me, it's about single responsibility functions. And I know that this is, everyone's going to have a way to deal with this, but if you split up your application, by the way, all your applications already are a bunch of functions. So when I say single responsibility functions, I mean functions that do one thing and do one thing well. And ideally, those functions are deployed separately in isolated containers. But maybe that's too big of a step, I don't know. But if they are deployed separately and they're named well, debugging becomes pretty easy. If I have an error on the get user contact form function, I know where my error is. I don't need distributed tracing. I can just go there and fix it. If you have a function that calls a function that fires an event that fans out on SNS and that calls thousands of another function, life gets tricky. And this is where you do need some form of tracing, and there's tools for this in AWS. It's getting kind of sophisticated at that point, but those are basically the last knife in your boot is this thing called X-ray, and then otherwise you're chasing logs. And actually yesterday, or maybe the day before, I heard someone say that serverless eliminates DevOps. I don't know if that person's done much serverless development. That's super not true. There's still lots of logs. There's still lots of grepping logs. There's still DNS. So,
Jeremy,
Yeah.
have you created any music videos that have created any controversy around the concept of whether serverless
Yes.
reduces your operations?
Yeah. Well, I mean, I believe the line was, "I'm going to reduce your ops, not
That's
I'm
right.
going to eliminate your ops." So,
But people heard what they wanted to hear
and
there,
people
didn't
did
they?
hear what they wanted to hear. Actually, Charity Majors. So I had a good chat with her. We had a good laugh about it because essentially she wrote an article about this. It was like it should be, "I'm going to improve your ops" or something like that. And I said, well, I mean, you write a Hamilton, it was like 5.5 minutes. It took me a while to write that. So, I mean, I'm like, you're limited lyrically about what you could fit in there. But no, we talked about it quite a bit. And I think the idea here is to say that, there is this contention, I think, where people like this hashtag #NoOps thing where it's like, oh, I don't need an operations team. It's like, well, maybe you don't necessarily need an operations team, but you still need somebody who knows the cloud, knows the infrastructure, can, again, interact with either a monitoring tool or with AWS's built-in monitoring tools and so forth. But it does significantly reduce a lot of that overhead. I used to rack servers as well. I think I have scars on my hand. Every time I opened up a server, I would always cut myself. I used to do that too, right? And we don't do that anymore. And I also don't have to worry about driving to the co-location facility at 2 o'clock in the morning to swap out a drive, right? Because the drive went down. Like a lot of that stuff is just gone. But then you get rid of having to upgrade operating systems and having to, do patches and all these other things that you might have to do. Or again, my servers just update in the background. Like I always have like the latest version of the server because they do it for me and I don't have to worry about it. So it significantly reduces a number of a lot of that, like, again, undifferentiated heavy lifting, everybody uses that term, but sort of the toil, right? The stuff that it just doesn't add value to your life. Whereas if you are on an ops team that is building modern applications using some sort of serverless technology or whatever you're doing, you should be spending your time optimizing the pipeline and the deployment workflows. You should be automating as much as you possibly can. I forget who I talked to, but basically have a rule that essentially anytime any type of request comes into ops, that the first thing they do is try to automate it. So if it's a request that it isn't automated, they try to automate it. And that's a really good process to do. And if you have people that can be dedicated to doing that, you can also start writing more scripts and writing more, so it's just, your ops gets so much better because you can focus on the things that actually matter as opposed to, I mean, not that keeping your servers running doesn't matter, but somebody else is doing that for you, right? So that's a big part of it.
IAM security is also another big part of it.
You need to know that, right? And having security experts that understand how to write IAM, I mean, essentially you do need to get a PhD. I think they offer it at Berkeley, I'm not sure, but you have to get a PhD in IAM in order to understand how a lot of those different things work. I mean, I wrote a post not too long ago about IAM with DynamoDB, and I had Alex Debris, who is the DynamoDB guy, say like, I didn't even know you could do that. And I'm like, yeah, there's all these things that aren't well documented and they're just in there. But yeah, the only other thing I say about observability is, and I think, there are a lot of observability tools out there. Lumigo's a great tool. Datadog's a great tool. I mean, these do really nice things. Honeycomb's an amazing tool. I feel like distributed tracing is one of those things where I have used it so few times that I'm not even sure it's not. I mean, as long as I have some spans, as long as I know that it called something or whatever.
CloudWatch Insights is pretty good.
It's pretty good. Yeah, I mean, and not that these other tools do better other things for you. The interface is sometimes a little bit better, a little easier to use, like the fact that they span across multiple regions and applications where It's a little bit hard to do that with AWS. But yeah, I mean, I do think observability is a huge piece of it. And again, it is not no ops. It's just a matter of I guess #better ops.
Yeah, I like the concept of you're moving your ops from a cost center to a value center. Right.
Yeah.
Yeah, good way to put it.
Yeah, so there's like ended up with like two topics, right? Like one around ops and where it's going, and the other around observability, which are fairly different, right? Like I think Seldo from our team, the NPN founder, he had a really good blog post with this like illustration of how complexity for developers day to day have moved up, and the complexity lower down has become really big companies, right? Like so one interesting piece, for example, back when we were all touching racks and servers and running to co-location centers, there were probably a lot less people doing that than there are today. Right? Like today there are way more data centers, way more servers, way more people doing that every single day, right? But we have companies that just do that basically, right? And we don't have to do it ourselves. And I think that's a continuous evolution that keeps like on the flip side, back when we were doing that, we didn't have to think about like responsive websites built for many different device types or mobile optimizations or performance over 3D connections and all of these different areas that now developers have to deal with, right? So we keep seeing the complexity shift upward in the stack, and we keep seeing companies taking care of the lower levels, right? Like it's not that it goes away, it's just like on the contrary, right? Like there are more and more people working in that, and I'm sure in the future there'll be a lot more people working in ops than right now just because software keeps growing, right? But we'll build layers of abstractions around it that allows us to, as developers day to day, focus on the value we're building for customers and not on the lower layers. And then when it comes to observability, like observability is an important thing of like that we often end up delegating to developers, that you might build a thing and you have it whole thing working and you can show it to your colleagues and everything, but before you can put it into production, you have to instrument it, you have to make it observable, and that ends up being a very long process often, right? Like it often takes longer to get that right than to actually build the thing, right? And that's why I think there's a lot of opportunity as we build more opinionated platforms. There's opportunities for us as Netlify to really say, like, if you build and deploy the web UI with our, like, with the architecture we propose, we can instrument it for you essentially, and we can make sure that the instrumentation is there, and then we can make it flow to the right places, right? Like, so we're now collaborating with Datadog, with New Relic, with Sumo Logic, with Logtail, and so on. And you can just enable one of them, and we'll start shipping the data there. They've prepared ready-made dashboards to make sense of it, and so on, right? Those kind of patterns, I think, makes a lot of sense. And when I think observability in general, I think about three things. Like, I think in the end, it's about, as developers, we want to know three things. The first is like, is our system working, right? Like, is it up or down? Is it performing with the right, like, performance? Are users seeing stuff fast enough? Are they able to do their things? And that's sort of one level of it. The other piece we want to know is like, when it's not working, how do I figure out where it's going wrong, right? Like, we want to be able to debug, and we want to be able to understand specific pieces of like how, like what went wrong and how can I fix it. And the third piece of it is basically like, what are the users of the system doing with the system, right? Like, so those are the layers we are thinking about, and I think we're doing more right now for is the system working, in terms of us being able to have like an integration into any of the common DevOps platforms and just get ready-made dashboards immediately, be able to see that. We're doing quite a bit with things like, if you open a deploy preview on Netlify, you will have like a panel on the side where you can directly see the serverless functions logs for the specific deploy preview you're watching, so you can easily click around, see what happens, get feedback, and so on, right? And I think we can still build a lot more tooling around that to make it easier to understand like what's wrong. And then I think there's another layer of more marketing tooling around like, how do we figure out what our users are actually doing with our system.
Right.
Yeah, and I like that mental model too. And I mean, and one thing you mentioned too is this idea of auto instrumentation, and or just understanding how to instrument. And one of the things that a lot of these observability companies do is now with like Lambda extensions, for example, and they can just go ahead and just put something in there, inject it into your runtime, and then because you're using the AWS SDK, they can hijack that, and they can detect a lot of those things and do that tracing and some of those other things that are happening there. As soon as you start adding things like Fauna, or maybe you're calling external systems or other APIs, now you've got a little bit harder to instrument those things or whatever. That's one of the same sort of approach again that we took with Service Cloud, is to say, like, if you want to write an API, you do API.get, right? So whether it's Express or whatever, who cares, right? It just does what you needed to do, and then you make a call to data. It's data.get, data.set. If you want to have an event, it's event.on to read an event, or event.publish. And the thing is that those abstractions themselves, because again we're building this in a way that is sort of an ecosystem, all of those abstractions can then be instrumented automatically for you, right? So we can understand what happens at each one of those because you control the larger sort of SDK around it. So I think there's a big challenge, certainly building with something like directly onto Lambda functions, where you do have a lot of different APIs you're interacting with, or different services that you're connecting to, and trying to do that observability and know sort of what's happening. All these observability companies are amazing, by the way. They're all doing awesome work. But I love that idea of like just take all those layers of stack. Like, is my thing working? Is it performing where it needs to? And then go to the next step and say, how can I optimize it, right? Which is that idea of like, well, maybe we deploy these to more edge functions, or do something like that, or do some code splitting. And then the last piece is like, from a business standpoint, like, is it actually giving me the value that I want from it? So interesting. But I think that the idea of auto instrumentation and just taking that away from the developer is another thing that gives you that instant feedback loop, hopefully, or that rapid feedback loop, and makes the developer experience, whatever that is, makes that better.
Yeah, I love the idea of the auto instrumenting too, and I think we're at a point now where the developer has so much control over these primitives and is defining their application at such a high level that we can get really good discrete information out just from the naming conventions alone. There's still, when we're integrating across a whole bunch of other companies, it's hard to know. We always blame ourselves, and then we find out GitHub's down, or like, Actions has been down a bunch lately, and it hasn't been great observability into when and why, and like, we'll be like, there's no way they're down. What are we doing wrong? And we're digging in further, and then it's like the notice comes up, and it's like, oh, seriously? Like, not again.
Corey Quinn and I walked by the Slack headquarters yesterday or 2 days ago, and I think we took down Slack. So I mean, it happens.
Just created a slight breeze, and servers blew up everywhere.
But I think you hit on a great point that both of you raised. I would tweak your question: is my application working? No, your application is not working. We're always building distributed systems, and distributed systems are always operating in a failure mode.
Right. Yeah.
And so it's is my system working ideally? Or is it working in the way that I expected? Because all of the aspects of the system under your control are working, but without the observability piece, you don't know that it actually was GitHub's fault.
Well, serverless also made everything backwards. So it did. So like in the old days, uptime was how we knew. Like I'd say, oh, did I get a 200 from my thing? Is it up? In this world where my function goes away, I don't want uptime. I want only invocations to happen when they're supposed to happen. Uptime for me is actually a negative metric. And so it's a weird world where now I want discrete errors, and I want good error boundaries, and I want good error reporting, hopefully through a dead letter queue that pumps into my Slack channel with a line number, so I know exactly what to fix and when. And that's a different mental model, because we're used to running these sidecars on these like monoliths. They're spread out, and you have a bug somewhere, and that somewhere could be one of 50 servers in a fleet, and maybe it's only one of the servers because one of the servers didn't get patched right, and like it's a weird bug, and so you need to watch all these servers individually. And now we've got this new model where we're like, I don't want to watch anything. You tell me when you're broken.
Yeah. Right. And I think actually you both get into the same point, or at least what I think is the shift from reliability to resiliency.
Yeah.
Where we're essentially saying, like, it's not is my application working or is it up and running? It's, is it working well enough, right, in order to serve my customer? And again, because distributed, everything breaks all the time, right? I mean, that is the classic line, and it's true. I mean, what we've run up against with like AWS control plane APIs, like, oh my goodness, like. AWS does a great job, but scaling their own control plane APIs, there's a lot of rough edges there, and because it's a hard problem. I mean, you're working with distributed systems, right? So being able to do that is tough. But I think that's the big thing of it, is like, if there is something failing, are you designing your systems in a way that allows part of it to load, right? So maybe I am getting some flashing gray boxes, here, and because my personalizations aren't loaded because that particular thing is down, but the core product stuff is loading or whatever. Or there's a fallback. Like, I mean, even this, the idea of rehydrating pages is great, where you could serve up a static page. Like, even if that page is 20 minutes, an hour out of date, may not be terrible as long as I can serve something to my customer, because I can't go ahead and rehydrate it. So, but again, those are design patterns that have completely shifted, and being able to know when those things are happening is important. And we don't have time to get into chaos engineering, but I mean, that's another topic that is probably worth exploring later.
This is why I'm loving Remix lately, because we're starting to see, I think, the front end community really re-embrace progressive enhancement, which is all about resiliency. People think it's about accessibility, and it is about that too, but it's also about giving your users an experience no matter what happens. And let's face it, shit happens. And you can't control the network. You don't know if that JavaScript got there. So having some kind of like reasonable HTML fallback is always a good option, way better than a skeleton screen that never loads.
We've got just under 8 minutes here. There's been a theme that I've seen weaving in and out of here, and it was actually, I had it separated into 2 topics. I'm gonna give them to you, and then let's just discuss as you see fit. There's been a lot of talk about conservation, right? You don't wanna measure an uptime. Uptime is waste. And that manifests itself in 2 ways. There's cost, and Simon Wardley said in December 2018, you're gonna need a better name than FinDev. But the idea back then was, listen, if everything is on a per function basis, then you can do financial operations, look at your code, and determine where to apply your optimization to receive the best results. The other fork of this question is conservation and environmental impact. And there is an argument that I don't think is made often enough, that serverless computing is better for the environment, especially with the release of things like the ARM Graviton 2 platform for Lambda, which was heavily adopted. So that actually does both. It saves you money, it saves the environment by drawing less energy into the data center. So should we be pushing the conservation issue, which I've heard throughout all of your responses, both financially and environmentally?
I think it will be an important part of what every cloud company have to do in the next 5 years, and so figure out like how do we actually understand the carbon cost of what we are doing? How do we allow customers to offset it? How do we use data centers and services that are sustainable? How do we measure that? I think the key problem around it that we're actually working with some companies on internally is figuring out just like how do we actually measure it, right? Like how do we actually understand the impact of different technologies? And it's extremely difficult, and there's a lot of companies now getting formed around like how do we measure that, but I think it will be an important part of like, it's probably the greatest challenge we face as a civilization right now. Like how do we get carbon neutral fast enough to avoid like a massive disaster, and all of us will have to play a role in that. And I do think that there's like inherently when we started thinking about like the Jamstack as pre-building as much as possible, right? Like obviously that saves just a ton of compute. It makes the system run a ton more efficiently. The more you can cache and pre-compute and not have to build over and over again, the lower your CO2 emissions will just naturally be, right? Like, so I do think there's an architectural approach there that optimizes for using as little compute as possible. That will be a net positive thing.
I think if I interpreted what you said right, you're saying that teams that run Kubernetes clusters are just as bad for the environment as big oil. Is that was that the comparison?
Not as bad as big oil,
Is that what
but maybe as bad or worse than the NFT thing.
Right, exactly. No, I think, but I think, yeah, again, serverless.
I went there.
From a hope there's no Web3 fans here. From the pure, energy standpoint, I mean, we have to remember too that there is a big server running behind the scenes that lets us run our serverless function. So there's something like Spot. I mean, one of the things that was mentioned before was like Spot instances, for example, are just sort of ways that you can buy unused compute because those servers are running anyways, and it's not particularly easy for them to just shut down a bunch of servers. Now, if anybody's ever had to scale their applications in AWS, you know that it involves a lot of trouble tickets and letting them know, by the way, I'm going to need this much compute, because if you don't, it's possible that they don't have enough servers turned on to handle that specific type of workload. So even just knowing that there could be a spike sometimes requires them to spin up more servers in order to handle those things. So the actual cost benefit of it is, I don't think we're there yet now. I mean, we don't have servers that, when you pull up to a red light that the engine shuts off and then it starts back up. Act like those drive me nuts. But anyways, so I think there's not a huge impact right now on sustainability from running serverless functions. I think we'll get there. I think it's a better place to be now. But I think, the amount that you're saving, it's like, well, I reused my napkin once. You know what I mean? It's minimal, the impact, but it's all worth it. And it's all stuff that we should be doing. And I think we need to get better. In terms of the cost aspect of it, though, I think if you're spending time trying to optimize your Lambda function right now, you are wasting a ton of time, right? You're creating more carbon dioxide just by spending the time to do that than you are saving anything there. So I think the bigger costs are going to be moving data, your data costs through AWS. If you're storing things in CloudWatch for some reason, you're paying a lot of money to store things in CloudWatch. Those things get expensive. Those are better optimizations if you're really thinking about cost. So if you're already running on Lambda or you're running serverless applications, some of these managed services, you're going to see, I think, cost reductions depending on the type of workloads that you're running, and that's already an optimization there. But overall, sustainability-wise, I think serverless is the way to go, right? Using managed services, not building these things yourself that are running idle for no reason. But it's not quite the massive green revolution that we're hoping for. There's still a lot of work that these data centers have to do to get that.
I will push back on that just a little bit from insider knowledge.
Okay.
The amount of packing that you can do on average onto Lambda instances, EC2 instances that are dedicated to Lambda, is much higher than customers achieve at the mean.
Right.
Across all other workloads on EC2 for the same types of things. So there is actually a step function, almost 100% additional workload at the mean state in terms of, what am I trying to say? Like in terms of available compute that's actually consumed rather than just burned for no reason. So there is a little bit more there, and then maybe this is a messaging thing that they're not saying that enough because they say it publicly but not emphatically.
Yeah.
They're just getting good at this. Last reInvent, they introduced a thing called the sustainability pillar into the well-architected stuff. And there's good writing there about how Amazon's approaching it. Amazon's got more money than God, and they're plowing it into data centers, and they're just building data centers everywhere. When you hear people talk about regions, you're thinking that, oh, that's a data center in a place. No. It isn't. A region is 4 data centers, at least in a place for redundancy in case of a catastrophic event, and they take care of replication in between those data centers. And these aren't just small data centers. We're talking city block of computers, floor to ceiling. The idea would be that they're going to amortize that cost, and they're going to drive that cost down. They're going to hit a point where it's more sustainable for them to pack that thing than it would be if you're running it inefficiently yourself. And I think that's probably true. And I think there's also going to be a nice little fight between the big clouds on who's doing a better job of this. Because I know I want to run my workloads in the greenest way possible because I'm scared shitless about the future of the planet. So I think it's obviously correct that we should outsource this stuff, and it's obviously correct that we should try and be more efficient with this stuff, and over-provisioning is a bad idea, and we should do more stuff up front that we can, and more caching that we can do, the better. On the finance side, Jeremy's totally right. You will create more carbon monoxide mouth breathing than you will save trying to optimize your Lambda functions. I mean, these things are cheap. We're talking 10 cents for a million invocations, so you can be kind of wasteful with them because they, you can have a whole bunch in your account, and if they're not running, and it doesn't really matter. Where you're going to get hit from a price perspective is going to be in your data, in DynamoDB or your logs, something like that. It is interesting. Simon's postulation was originally with FinDev that we'd be able to look at an application and know which functions made us money and which ones were a failure, and so we would have a way to measure our dev teams better. And it's kind of a terrifying prospect to me. And also just on the cost basis, I mean, if a function gets invoked 3 million times and it's 30 cents, did that person do a bad job? I don't know. It depends on how much money that function made, I guess.
Yeah. Or if that's your authorizer function, then it doesn't matter because it gets called for everything, and so it's important no matter what.
Yeah.
Matt, Jeremy, Brian, we're at time. Thank you so much for joining for this panel today. Appreciate it. Thank you all for joining us. We hope you learned something. I'll get to you.